Assalamu alaikum and good morning. Today I will be presenting our smart environment monitoring system. This is our team, Group 8. Our team leader is Batyon. Our team members are Atika Kaisara, Edward Tian, and myself, Omar Ahmed. The problem that we have is environmental monitoring can be challenging in remote areas due to inaccessibility, lack of real-time data, and fragmented data collection. Our proposed solution is the environmental monitoring drone system that can fly over large areas to collect real-time data with integrated sensors like air quality, humidity, temperature, and camera sensors. Introducing our chosen drone, which is the DJI Matrice 350 RTK. Our drone platform is based on the 350 RTK equipped with advanced H20 camera. The sensor was integrated to measure humidity and temperature. It was also integrated to detect radiation. Our chosen architecture is the three-layer architecture, which has the perception layer that is collecting sensor data from the sensors, network layer, which is Wi-Fi and LoRa transmit data, an application layer which analyze the data with AI for smart actions.
To conclude, the drone is equipped with four main sensors: the Zenmus H20 camera, a CO2 sensor for detecting air pollution, the HTU21D sensor for measuring temperature and humidity, and the LND71210 Geiger counter for detecting radiation. The environmental data collected by this sensor will be transmitted to a cloud service, and then AI-based analysis will be performed and the result will be displayed. Now, let me show you a short animation that demonstrates how our drone system works. Imagine we are collecting data from wildlife tracking in a rural forest. In this case, our proposed drone becomes the ideal solution. First, we power on the drone's remote control. A home page appears on the screen. From here, we can build the geozone map to check whether the current area is a restricted or authorized zone and monitor the current flight status and altitude. Next, we set up a mission by creating a flight route. We use the waypoint feature to mark key coordinates for the drone to follow. Once the mission is uploaded, the drone takes off and begins to fly autonomously. However, we can manually override its flights at any time if necessary. While in flight, the drone captures image and video and simultaneously collects environmental data such as humidity and air quality levels. Then, all collected data is then automatically uploaded to a cloud database. After that, researchers can log into a web dashboard from any computer to view real-time data updates, access image and video records, analyze charts, maps, and AI-generated insights, as well as download reports or receive alerts for abnormal environmental readings.
Hello everyone, so here I would like to give a brief explanation on the UI of the drone, which is the remote controller. So this is the hardware or model of the remote controller itself. So we have few buttons and 15 features, but the most important part is that I would like to explain the touchscreen, which display this homepage of the app. The app called DJI 2 app, where it display a bunch of section. This is the geozone map, cloud surface, planning a flight route, album, as well as academy, which is to download any sort of manuals. And then this one is to see the status of the drone. And then once we enter the camera view button, it will automatically display this page, which is the first person view camera view. And then it is actually to shows the live video feed from the front facing FPV camera mounted on the drone itself, so we can take videos, take some photos, and basically just monitoring the whole operating area. And then the top bar is to see the status, flight or remote control status, the battery level, and so on. And then next is the geozone map. It's basically to see whether the operating area is actually a restricted zone or flyable zone. So as you can see here, and then lastly is to set a waypoint. So from here we can see that the X is the starting point, so but we can also reverse it, making it to making the drone go back to the starting point by reverse path. And then we can also delete certain waypoint that we want, and then this one is for POI, or point of interest. So once we press this button, we can create a new waypoint by just naming it whatever, and then we can select the aircraft, and then we can save it through this button to create a waypoint, and also plan a route. So this bottom bar would be the information displayed, so as well as the distance for the whole route, and then the time reaching starting point to the end point, and then how many waypoints that we have, and how many photos that we have taken. That is all from me. Thank you.
Next, I will talk about our web design for our drone system, which is the DJI Matrix RTK350. So as you can see, this is the login page for the web design. And when the user press sign in or login, it will bring them to the home page, which shows them the drone location. And then above, you can see three widgets that navigates users to three different locations. So we have the first one, drone status, and when you press into it, it shows the battery, remote controller, and image transmission of the drone. Like you can see the percentage and the status of it, like normal or bad. So below that, we have the payload. User can see if the payload are currently occupied or empty. And then at the left side, user can see the current speed, the signal, and the altitude of the drone. So next we will have the environment data. The user can see the wind status, visibility, UV index, and the humidity on over here. And then below, they can see the geozone and also the current camera and the CO2 temperature and radiation detected on the environment. So that's all for environment data. I will move on to AI insights. So on AI insights, the user can see the graph comparisons of different kind of sensors, and then below it, they can see the tons of rain, which is the prediction of AI of when it will rain, and then the graph of it. So when they press the export PDF file of the AI analysis, it will show a more detailed report of the analysis of the AI. As you can see here, we have the sensor overview, which shows the reading of each of the sensor types, such as CO2, temperature, humidity, and radiation. And then we have the AI prediction that talks about the next 24 hours trend of each of the sensor. And then we have the anomaly detection results. And then lastly, we have the recommendations of the AI assistants that shows what to do with the result gotten from the sensors. So that's all from me. Thank you.